Now listen. So what do we mean by system? This is the first term we need to understand. If I put a question like this, I'm saying system. Then what does a system mean? It is anything under observation or anything under study is what we call it as system. Okay, accepted. Then here we are saying system of particles. So what exactly are we going to do? What do you mean by a particle according to physics? So what do we mean by particles here, guys? I want some response. So particles means point masses, right? That is, if the size is small compared to the distances they travel, then we call it as particles, right? That is what physics says. So here system of particles means we are trying to speak about collection of such particles. Okay. And for those collection of particles, the main concept that we are going to learn is something called as center of mass. Okay. So this is the first concept or the first part of this chapter. To put it clearly, what I would say is system of particles mainly deals with center of mass, COM actually. And rotational motion has something to do with rotation of an object. Okay, it is different from a circular motion. That's a different story. We will see it when the time comes. Okay, so before that, let's first try to understand what the center of mass is. Before we answer what is center of mass, we need to understand what is mass. Right? What is mass?
The amount of matter that an object has.
Very good. So it's the quantity of matter that is present. That's right. So you talk about the quantity of matter. Right? We would have discussed this many times. Mass is different from weight. Okay. So the quantity of matter present in a substance is what we call it as mass. Then what do we mean by the center? Then what exactly does center mean? That's another important point to be answered, right? So center is a mathematical term. If so, mass is physics term. Center is a mathematical term. So what if you combine both, what idea is it coming? What do you mean by center? So center is mainly defined for a circle, right? So how do we define that center as? Center is a point with respect to which we draw some, we can draw a shape which is symmetrical about it. Okay, that's how we can define it. Now if I put the same question like this, then what exactly is center of mass going to be? Is the concept of center of mass applicable only for spherical shapes and the circular shapes? So these kind of questions run in our mind, right? So the answer to that question is center of mass is applicable for particles of any random shape. Center of mass is applicable for any random shape. Okay. So it is a point where what should be concentrated is point where the whole mass of the system is concentrated. Okay, that is, let's say I give you a box. Okay, I give you a box in which there are different, let's say small thermocol balls are present. They're present like this. Okay, So each thermocol ball is going to have some mass associated with it. M3, let's say there are n particles. Let's say the nth particle is this Mn. I hope you're able to visualize it, right? Now the question is, all these thermocol balls put together is what is called a system of particles. And my important and my concern of study is going to be, my interest of study is going to be, where is the center of this particular system? Then what we can say is, instead of saying these many balls are there, you can replace it with one particular mass of capital M. Okay, let's say it is located at this point. Then this point will be called as the center of mass of the system of particles. So to put it in simple terms, what I'm trying to say is, when you have a system of particles, you can always replace the whole system with one particular point where you can say the whole mass is concentrated, and that point is what is called as center of mass, and that is going to be our study. Am I clear till this point? Am I clear?
Yes, sir.
Yes, sir.
So this center of mass. Okay. 1 minute. Now see. So this is all about center of mass. Okay. The next concept I'm going to introduce is called as moment of force. Okay. The other name for moment of force is called as torque. There is a reason why I'm introducing this. Okay. This torque has something to do with rotation motion, but this is a concept which you need to know beforehand itself. It is then I can make you understand the significance of center of mass. We know what is center of mass, but the question is, why do we need the center of mass is what we need to answer. Right. So for that, we will have something called as moment of force. Okay. So I'm switching on my video. You guys can see it. I'll show you practically. Observe. Is it clear now?
Yes, sir.
See, what I'm doing is, let's say I have this pen. Now, I'm holding this pen in such a way that it is under balanced condition. So what do I mean by balanced condition? When I say something is balanced, in terms of physics at least, when I hold this pen, if I don't hold it here, what would have happened? If I remove my hands, if I remove my fingers, what will happen is the pen is automatically going to fall down. So when it is going to fall, it is experiencing an unbalanced force. Am I right? It is experiencing unbalanced force, meaning of this. There is only weight acting in the downward direction, so it is unbalanced. But in this scenario, can you tell me what exactly is the physics involved behind this concept? When I hold it here, which force is trying to oppose the weight of this object? Sorry?
Force exerted by hand.
Okay. What force is the hand exerting on this pen?
Muscular force.
Sorry?
Muscular force.
External force. Did you say external? Mithun, no, I'm sorry, I'm not able to hear you. There is a lot of background noise. It is actually the friction that is acting between, the pen is actually trying to move in downward direction, but my finger is trying to block it. It is because of the frictional force acting between these two. So whatever I've answered here is purely in terms of force. Okay? And one important point to be kept in your mind is, in this whole world, force is the one which is responsible for translatory motion of an object. when I say translatory motion, it means the object to move in a straight line path. If an object has to move in some linear path, then force is necessary. Okay. But now, what was the term I introduced? I told something called as moment of force. It is not force. It is moment of force. What does that moment mean? Moment has something to do with rotation. Okay. So I can give you an example like this. For example, again we'll go to the atomic structure in your chemistry. When you study about the Bohr's concept, right, the Bohr's postulates, they say that electrons revolve in those orbits where the angular momentum is quantized. Angular momentum, the momentum is there, right? Before that, there is angular. That is also something related to momentum. Okay. So, what exactly I'm going to do is, I'm trying to balance it. Am I clear with this point? But see, here I'm able to balance it. Now, when I say balance, it is not moving in a linear path, nor it is rotating. Okay. But see, what will happen if I shift my hand? Instead of holding it here, I'm holding it here. Okay, I'm not applying any pressure. What do you think once I remove? What do you think will happen once I remove my right hand?
It will
Now we are
lean.
going, huh?
See, what will happen is you're able to see what happened.
It will lean down towards one side.
So, what exactly was happening? Was it having a translatory motion or a rotatory motion? Now I rotated because there is a lot of friction here. I'm able to sense it. Okay. If I don't apply any pressure, see, you're able to see naturally happening. I'm trying to hold it like this. I'm not applying any pressure. It is naturally rotating. I didn't even move my hand. Right? Question is, why is this happening? Why are we able to see that there is a rotation? So with respect to you, me, when I see from this side, right, I am able to see that it is rotating clockwise. With respect to you, it is anti-clockwise, right? I am holding it here. If suppose I try to hold it on the cap, what do you think will happen?
It will rotate clockwise.
With respect to you, it will rotate clockwise. See, I did nothing. It rotated. I didn't apply any pressure. Okay. Whereas when I held it here, what was happening? It is exactly at the balance condition, meaning it is neither having a translatory motion nor a rotation motion. It is not rotating. Am I clear to this point? So we need to come up with a concept. We need to understand what exactly the center of mass is. So this pin is made up of many particles, right? It is made up of many such particles. Now, if you replace all those particles with a mass of capital M and place it at the point where it is not rotating, then I am holding this pen at which point?
Center.
Center of mass.
Center of mass of this pen. In a similar way, if I take, say for example, I take this cup. Okay, I take this cup, I am holding it like this. It's not rotating. Whereas when I hold it like this, you're able to see. I'm not able to balance it because I'm not holding it at the center of mass. You're able to understand this. Similarly,
Yes.
you can take any device for that matter. I got some random thing in my hand. I'm trying to hold it like this.
Sir,
I'm
why
not able
is
to balance it.
sir,
I'm not able to balance it.
sir,
Yeah, tell me.
why is the object rotating like that, sir? Because of force, sir.
That's what I'll explain. That's what I'm going to answer. So I'm trying. My objective is I want to hold it horizontally, but I'm not able to hold. I'm holding it at a particular point. You see, it is rotating. Whereas there I can definitely find one particular. See, I'm not applying any pressure. There is no cheating. I'm not. You're able to see it. Is it rotating? So this is going to be the center of mass. What will happen once I cross the center of mass and hold it somewhere else? You're able to see here, no rotation. On the left of center of mass, clockwise rotation. On the right of center of mass, anti-clockwise rotation. So what happens? You're able to understand. You're able to visualize it.
Yes, sir.
Yes. That is happening because of a concept called as moment of force, which is technically called as torque. So for that you need to understand something. So I hope you have visualized it. So you ask me why that is happening, because why it is happening is, when I hold it here, I come back to the pen. When I hold it here, I'm holding it in such a way that mass on the left hand side and mass on the right hand side are the same. Okay. Whereas when I hold it here, what is happening? Why is it tending to rotate in the clockwise direction with respect to you? It will have the tendency to go down only if there is more mass concentrated on this side compared to the other side. Are you guys able to understand? So center of mass is such a point where on either side of it, the mass will be equally distributed. Means it will be under balanced condition. So being under balanced condition is what is the significance of center of mass. Generally, technically, that point should be called as center of gravity. Okay. But since we are dealing with small objects, I will say center of mass and center of gravity. Yes. I want you to visualize this aspect. Am I clear with this?
Yes, sir.
Yes. Now see, I'll give you a formula. So I'm going to discuss about moment of force. Let's say for this particular part, the center of mass is here. Then mg will be acting in this direction for this part. Okay. 1 minute. Yes. For this particular part, there will be a mass, right? We're able to visualize, guys. So let's say this particular mass is m1 and this particular mass is m2. Okay, and this is the center of mass. So this part m1 will have its center somewhere over here. Okay, it means if I break this pen and I take the small part, okay, if I break this pen and I take the small part, then it means for that small part I need to hold it here so that it is balanced. So for that small part, this will be the center of gravity. That is the center of mass also. Are you guys able to visualize? So m1, the mass of this side will act in this direction. The mass of this side will act at its center. Okay. So this weight will try to put the object in clockwise rotation with respect to me, anti-clockwise with respect to you. And this side of the mass will try to put the object in anti-clockwise with respect to me and clockwise with respect to you. Are you guys able to understand? Okay. So this side mass is putting the object into clockwise, and this side mass will try to put it in the anti-clockwise. So here it is able to rotate like this because which one is succeeding? The right part is succeeding. It is able to exert more amount of torque. Okay. Now let's look at what is the mathematical expression behind it. Okay. Now, so this moment of force, suppose I take this pen as an example. Okay, I can hold the pen anywhere I want. The best example for this is a seesaw. Right? Let's say one person is sitting here, the other person is sitting here, and the seesaw will be hinged exactly at the center. First person, second person. The first person's weight will act in the downward direction, m1g. The second person's weight will act in the downward direction, that is m2g. You're able to understand this? This is the axis of rotation. Why I'm calling it as axis of rotation is because this is the point about which the whole seesaw or the system is trying to rotate. Okay. So if I take this distance as x1 and this distance as x2, okay, then force into perpendicular distance is what is called as moment of force. Force into perpendicular distance is what is called as moment of force. Okay, this is the formula. I hope this is clear, guys. So mathematically, we write it as m1g. So perpendicular distance, make a note of it. From axis of rotation. So m1g into x1 is the, so m1g into x1, it will try to put the object in anti-clockwise direction. So this is called as anti-clockwise moment. Am I clear? Similarly, m2g, one minute, small change. I'll call this as x1, this as x2. So m2g into x2 is what is called as clockwise moment. Am I clear, guys, with these 2 points? So m1g into x1 is the anti-clockwise moment, m2g into x2 is the clockwise moment. Means this force multiplied with the perpendicular distance from axis of rotation is called as moment of force. Is it clear?
Yes, sir.
Now listen. So what happened with respect to center of mass? So with respect to center of mass, the whole system is under what condition? Balanced condition. So when I say balanced condition, meaning the particle will neither have a straight line motion nor a rotational motion. Am I clear? Okay, now listen. What I'm going to do is, if I take this point as M1 and this point as M2. So I have a two particle system whose masses are M1 and M2. Okay. We have two masses which are M1 and M2. Then I'm taking some random point as origin, and M1 and M2 are lying along x direction. Is it clear? Okay. So let's say this M1 is at a distance of x1 from the origin, and M2 is at a distance of x2 from the origin. Clear? Now let's say the center of mass of the system is somewhere over here. Let me say there is a point B. There's A, B, and O. Any doubt, guys?
No.
Okay. So from O to P, if I call this distance as the x coordinate of center of mass, okay, then what is AP, guys? AP is,
2 minus x1.
it is x coordinate of center of mass minus x1. So if I take A, P, and B, the 3 points are collinear. So the distance between AP, you observe it, no? X coordinate of center of mass minus x1. What is the distance PB? X2 minus x coordinate of center of mass.
What is x coordinate of center mass, sir?
What is
X coordinate of center mass, sir.
XCM? I put it here, no? That is called XCM. XCM is the x coordinate of the center of mass. Shall I proceed? Okay. Now here we have mass M1, here you have mass M2. So M1 will exert a force in the downward direction. What will be the force exerted by it or experienced by it? It is M1G. M2 will experience the force of M2G. So what is the significance of point P? Clockwise moment should be equal to anti-clockwise moment. Why? Why should this happen? Because the system should not rotate. Is it clear?
Yes,
Yes
sir.
or no? Because system should not rotate. So what is a clockwise movement according to the diagram? So which force has the tendency to rotate the object in the clockwise direction?
Force B.
Force at B. So this will put the object in clockwise rotation. This will put the object in anti-clockwise rotation. So clockwise movement, can I write it as M2G multiplied with the distance between B and P? M2G multiplied with BP. So that is nothing but M2G into, what is BP, guys? X2 minus X coordinate of center of mass. Accepted? Similarly, what will be the anti-clockwise moment? It will be M1G multiplied with what? Multiplied with AP. So that will be M1G into, what is AP? X coordinate of center of mass minus X1. So, but what did I say? The significance of point P is clockwise moment is equal to anti-clockwise moment. When that is the case, then M1G into X coordinate of center of mass minus X1 should be equal to M2G into X2 minus X coordinate of center of mass. So what will get cancelled? G is gone. M1 into X coordinate of center of mass minus M1 X1 is equal to M2 into X coordinate of center of mass minus M2 into X coordinate of center of mass. So bring this to the left hand side and M1 X1 to the right hand side. Then you will get M1 plus M2 into the X coordinate of center of mass is equal to M1 X1 plus M2 X2. So what will be the X coordinate of center of mass? It will be M1 X1 plus M2 X2 divided by M1 plus M2. Did you understand this? So this is the X coordinate of whom? Of center of mass of a two particle system. So what are the two particles present in the system? M1 and M2. So this is the X coordinate of the center of mass of a two particle system. Make a note of it.
So it is different from torque, no, sir?
Sorry?
It is different from torque, no, sir?
No, torque, moment of force is what is torque. I wrote no. Clockwise moment I wrote no. Clockwise moment is clockwise torque.
Okay, sir.
To put it in very simple term, torque is nothing but rotational force.
Sir, no, sir. This formula is used to find for what, sir? Like this formula is used for what?
Center of mass. To find the center of mass. This formula is used to find the X coordinate. Listen, mute yourself. This is used to find the X coordinate of center of mass of a two particle system.
What is that XCM, sir?
That's what I wrote at bottom. X coordinate of center of mass.
No, sir. X2 is from sir. X2 is from P to B, sir. Like that, from XCM is from where to where, sir?
Where did I write X2 as? You first write it down, you will understand. All the distances are measured from the origin only.
Okay, sir.
you all copy this. I want you all to copy this.
So 1 second.
Right.
Sir,
Get it.
sir, can you scroll down a little bit, sir? Thank you, sir.
Done? Yes. So this is the x coordinate of center of mass. Why this is a derivation I've shown you. So it is very simple, guys. Okay, it's very, very simple. So it is for applicable only for a particle system. It cannot be used for extended objects. Means it cannot be used for pen or cup or whatever it is, whatever I've shown. It should be of a point mass. Suppose there are multiple masses which are placed along a linear path. Okay. Then if you want to define the x coordinate of center of mass of the system, remember xcm is always the distance from the origin. Okay. So in this chapter, especially when you're solving with problem based on center of mass, they will not give you origin. You are free to choose your own origin. It is up to you. Means you can take any one of the particles to be the origin, or you can take the origin to be somewhere outside also. If you take this as the origin, then with respect to origin, you need to mention the x distance and the y distance of all the particles that are present. Here, in this case, the particles are present only along x direction. So if you take this distance as x1, this distance as x2, if this as x3, and this as x4, let's say it is going on like that. Then what will be the coordinate of point mass m1? It is x1 comma 0. Coordinates of the second point is x2 comma 0. For third point it is x3 comma 0, and the fourth point it is x4 comma 0. Accepted? Then if you need to apply the formula, then it is very, very simple. Multiply the mass with its corresponding x coordinate. m1 with x1, similarly m2 with x2, m3 with x3, and m4 with x4. The whole divided by m1 plus m2 plus m3 plus m4. So to put it in simple terms, the x coordinate of center of mass of the system is the sum of the mass multiplied with its corresponding x coordinate divided by the total mass. Similarly, if there are n particles, it will go until mn into xn. This is how the formula goes. I hope it is clear. In a similar way, it is not necessary that every system in this world will be confined only to x direction. It can be along y direction also. If it is y center of mass, then what will be the value? m1, use the logic and tell me. m1,
y2,
m1, y1, plus m2, y2, plus m3, y3, plus so on. It will go until mn, yn, the whole divided by so on till mn. Okay. The same thing is applicable even for z coordinate of center of mass. If it is a three-dimensional object, then you can apply it like this: m1 z1 plus m2 z2 plus so on till mn zn, the whole divided by m1 plus m2 plus so on till mn. Are you guys able to understand?
Yes, sir.
So this is all about the coordinates of center of mass along x, y, and z direction for what kind of a system? For particle system. Have this in your mind. Okay. So based on this, I'll give you a small problem. You can do this. Let us say there are 3 particles which are placed at the vertices of an equilateral triangle. Okay, there are 3 particles, each of mass m, that are placed at where? At the vertices of an equilateral triangle of side A. Okay. Now your work is to define the center of mass of the system. I don't want any guess. I want an accurate answer using mathematical expressions. How to proceed?
Sir, what should we find, sir? Can you say it again?
Center of mass.
So we should take an origin point first.
Yes. Very good. First and foremost step is you need to consider origin. So you can ask me the question, where do I take the origin? It is up to you. I told you, no, origin in this chapter is, you're free to choose anywhere you want. Okay. But the smarter way would be to choose at any one of the masses itself so that the x and y coordinate of that particular mass will become 0. You will reduce the calculations. So what I will do is, I will take the origin to be at point A. Am I clear, guys? So this point will be 0, 0. If that is the case, with reference to origin, what will be the coordinates of point B?
All have equal mass, sir.
Yeah, equal mass.
M, 0.
See, it has nothing to do with mass. I don't know why you asked that question. It has nothing to do with mass at all. So with respect to origin, what is the coordinate of point B? From origin, how far is it along x direction?
A, 0.
It is A, 0 because it is lying along x direction. Right? What about the point C? That is what we need to answer. For this, we need to apply a little bit of mathematics. Okay. So if I drop a perpendicular for an equilateral triangle, there are certain properties which we know. What are they? When you drop a perpendicular, this distance will be A by 2. Because for an equilateral triangle, the altitude and the median are the same. So this will be A by 2. So from this, I am clear that the x coordinate of this particle is A by 2. But what do I say for the y coordinate? I don't know what is the distance. How do I find that y coordinate?
Half base into height.
Half base into height is going to give you area. We have nothing to do with area. It's, if you take this as 60 degrees, you know the applications of triangles, right? Let's say this distance is y, or I will call it as yc. Then what is yc divided by a by 2?
Tan 60.
Root 3.
So tan 60, that is going to be root 3. So yc will be equal to root 3 a by 2. So a by 2 comma root 3 a by 2. Is there any doubt, guys? A by 2 comma root 3 a by 2. Accepted?
Yes, sir.
Now observe. What will be the x coordinate of center of mass? It will be m1 x1 plus m2 x2 plus so on. Or here, since there are 3 particles that are present, plus m3 x3 the whole divided by m1 plus m2 plus m3. Accepted? Similarly, y coordinate will be m1 by 1 plus m2 by 2 plus m3 by 3. So m1 x1. m1 is how much? M. Right? M into, what is the x coordinate of the first particle? This is the first particle, second
0.
particle.
A by 2.
Yes. So m into 0 plus m into, what is the x coordinate of the second particle?
A.
That's right. A plus m into, what is the x coordinate of the third particle?
A by 2.
That's right. The whole divided by, what do I get? m1 plus m2 plus m3 is 3m.
3.
So ma plus ma by 2 will be 3ma by 2, the whole divided by 3m. 3m and 3m will get cancelled. Answer will be a by 2. So the x coordinate of center of mass is a by 2. You're able to understand this? Similarly, I want you to find the y coordinate of center of mass and tell me. Go tell me. For those who want to copy this diagram.
Sir, a by 2 root 3, sir.
Yes, sir. Even I got it.
A by 2 root 3.
Yes, sir.
I don't know. Let me check. So y coordinate of center of mass is how much? m1 by 1 plus m2 by 2 plus m3 by 3. The whole divided by m1 plus m2 plus m3. So what is it? M into 0 plus m into 0 plus m into root 3a by 2, the whole divided by 3m. So we'll get it as a by 2 root 3. Right? If you observe what that a by 2 root 3 is, so the center of mass is coming somewhere over here. Because it is a by 2 is somewhere on this line. And what is the y coordinate? A by 2 comma a by 2 root 3. What is the meaning of this case? So this is going to be the center of mass of this triangle where the masses are placed at the vertices. You're able to understand? If you check what this point is exactly the centroid of the triangle. Okay. So what we can conclude from here is when you have a system which is of equal mass, then the center of mass will exactly be at its geometrical center. Okay, and if it is a symmetrical shape. I hope it is clear, guys. Next. What I'm going to do is I have, so this is the second problem. I have two masses of values m1 and m2. Let's say which are separated by a distance r. Okay. I don't know where the center of mass is. Let's say the center of mass is considered to be at point P, which is at a distance x from m1. I want you to write the value of x in terms of m1, m2 and r.
Sir, can I say the question again, sir?
There are two masses of values m1 and m2 which are separated by distance r. From point A at a distance x, there is a point P where the center of mass of this system is present. I want you to write the answer for x in terms of m1, m2 and r. Again, the same logic only, nothing else. You just need to go with simple origin concept and that's all. Try it.
So could you tell what is R again?
R is the distance of separation between M1 and M2.
Okay.
This distance is R. Okay. Now see. Anybody with the answer? It's very simple. I don't know why you're taking so much time. So what do we need to do? We need to consider something as origin. So I told you, no, whenever you have many particle system, take one of the particles to be the origin. So take this as origin. So what will be the coordinate of point P?
X, 0.
What will be the coordinate of point B?
R minus X.
R comma 0. Why is it R
Sorry.
minus X? So apply the formula. X is equal to M1X plus M2R divided by M1 plus M2. Did you understand what I did? I applied the formula of x coordinate of center of mass. What is the x coordinate of center of mass in this question?
P.
It is at a distance. X coordinate is x only. M1 into what is the coordinate of point 1? X coordinate of point 1? 0. M1 into 0 plus M2 into R divided by M1 plus M2. So it will be M2R plus M1, M2R divided by M1 plus M2. Are you guys able to understand this?
Yes, sir.
Okay. Now, observe what I'm going to do is M2R divided by M1 plus M2. Then, so this is nothing but AP. So what is BP? BP is nothing but R minus X, right? R minus, what is the value of X? M2R divided by M1 plus M2. Okay, this is also accepted. So it is M1R divided by M1 plus M2. This is going to be what value, guys? This is the distance BP. Right. If I ask you what is AP divided by BP, AP divided by BP is M2 divided by M1. Correct or not?
Yes.
So I'm producing certain cases. See, if M2 is greater than M1, what can we conclude? If M2 is greater than M1, that implies AP is greater than BP. What is the meaning of this? From this, can I conclude that the point P, that is the center of mass, is close to M2? Yes or no? So point P is close to M2, or I can put it like this. P is close to heavier mass. Okay. So this is a very, very, very important conclusion. So here an important note to be made is center of mass of a system will always be close to the heavier mass. That is why you can try to hold the pen and see. If you try to hold the pen exactly at the center, it will rotate. But if you hold it near to the cap, it will not rotate. Means the center of mass is close to the cap because the cap added to the pen will have a slightly greater mass compared to the other side of the pen. Are you guys able to visualize this? So center of mass of the system will always be close to the heavier mass. This is a very, very, very important point to be kept in mind. Right? Clear or not?
Yes.
So make a note of it. Okay. So that's it for today's class. Just wait for a minute, don't leave.
So I have a doubt.
Yeah, tell me.
So center of mass of an object can change depending on what you attach.
Yes. See, for example, let's say I have a rod. Okay, a rod. You have seen a wooden scale, right? Let's say I
Yes,
have a
sir.
wooden scale of 30 centimeter. If I put a question like this, where will the center of mass of the scale be? You can directly tell the answer.
15 centimeter.
Exactly at 15 centimeter it is going to be. But what I'm doing is, I'm taking an aluminum foil, I'm trying to crush it, and I keep on top of it. Okay. Or I will say, I've taken some clay and I've stuck on top of it exactly at 30 centimeter. Now, do you think the center of mass will still be at 15 centimeter? I'll give you two options. Do you think it will still be at 15, or it will be at a value which is less than 15 or greater than 15? With
Will be
respect
greater
to
than 15.
with respect to origin, with respect to the point 0, where will it be? Will it be less than 15 or greater than 15?
Greater than 15.
Yes. So that is what this point means. It is close to the heavier mass. You're able to understand? So if you change the system, the center of mass of the particular system will also change.
Okay, sir.
Okay. So this is what happens. Any other doubt? Anyone else with any other doubt? Okay. Just wait for a minute, don't leave.